made it appropriate for viewers under the age of 13, which should have fixed the problem for those of you that have not been able to get into it. Is anyone using their laptop instead of their phone at the moment? Okay. Hey, look, it's me. All right, so there's still about 16 people I'm showing logged on at the moment. I want to give just a couple more moments before we get going. Alrighty. Good times, good times. I figure I'll start doing the notes in about 4 minutes. Afterwards, if there are issues that you guys are noticing, let me know, and we can work on fixing it. Yeah, I'm still showing that the laptops are not... I'm still showing that the laptops are not really allowing use. So all I can think of is phones for the moment. If the whole thing doesn't pan out, then we will... I'll just go ahead and upload the video. No, you're not going to be able to write anything on the PDF that you've got in your folder. It's just a print. It's something you print off or look at it. That's how I usually have it saved in there. Well, no, as far as being able to write it down, you would need to print it. I'm not sure how you would write with it otherwise. All right, well, let's, no. I'll give it another 2 minutes while we try and get some of the kinks out then. Yeah, I'm not sure what a G Suite account is. But I'll look into that. It sounds like it's a laptop restriction rather than a particular issue on this side, so I'm going to need to play around with it. I'll get on Annie's laptop and go back and forth and see what kind of restrictions are on there from the video standpoint, because folks who are going on their phones are being able to access it. As far as the notes, yeah, you could print off the PDF that I've got in the folder for you. If you, I guess I could make a separate folder for you guys later that can be written on using your laptop screens, the touch screen feature. I guess just bear with me a smidge while we, like I mentioned to the folks who were with us Friday, I've uploaded videos before, but I have not done anything live. If it doesn't quite pan out, then well, what I can do, either I can have you guys using your phones, or I can go off and come back on again in an attempt to see what it is that is not letting the school laptops connect, either from my end, or I'll email the folks at central office and say, hey, why can I not connect? The only thing I can think of off the top of my head, but I would have to come down, and I don't know how long it would take. I would need to go back into my channel settings and make that quote unquote kid friendly. If you're not able to access the page at all. But I got 25 people looking at the moment, it seems. All right, I'm going to go ahead and start doing notes, and then, well, I'll communicate with you guys throughout the day if there's any major issues, questions, comments, queries, conundrums, quandaries, concerns about how it's all working. We'll tackle it for another time. If the live broadcast doesn't end up working, I can go ahead and just pre-record them for you guys. All right, well, here we go. So, the Fundamental Theorem of Algebra. That's what we're going to talk about here. It states that a polynomial function of degree of n has exactly n complex roots. Okay, now complex roots, if you remember from before, that's all the numbers. That's your real numbers, imaginary numbers, rational numbers, irrational numbers, everything. Okay? And that does, well, like I said here, include any imaginary ones. Okay? If it's a complex root that has either, well, that have imaginary components, they always, 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 always occur in pairs. And I think we talked about that a little bit when we were doing that unit. All right. So if the statement A plus BI is going to be one of our roots, then its conjugate A minus BI is also going to be one of the roots. They always have to travel in pairs. The same also applies for if we're talking about a radical, where it would be like A plus the square root of B and A minus the square root of B. The same pairs and conjugate restrictions still apply. All right, so let's look at this one. F of x equals 5x cubed minus x squared plus 5x plus 1. The degree is right there, 3, which means it's going to have 3 roots. All right. Now, I've got 4 numbers here, positive and negative 1, positive and negative 1/5. These are the numbers that I'm going to call worth trying. Okay. Some of them could be roots. Some of them might not be. And since we're really delving into the whole, are these roots, are these knots, I highly, 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 highly recommend, for the most part, starting with positive and negative 1 and just kind of work your way up from that. More often than not, the ones that I'm going to be giving you will have either 1 or negative 1 as one of its roots. Okay, so let's go ahead and set this up. We're going to do 5, negative 1, negative 5, positive 1. Well, let's go ahead and do 1. All right, bring down the 5. 1 times 5 is 5. Minus 1 is 4. Times 4, or times 1, is 4. Negative 1. Negative 1. Remainder 0. Okay, so we know that 1 is one of the actual roots. Okay, these are our k values. All right, now we can use this depressed polynomial here. All right, let's try negative 1 this time. Okay, bring down the 5. That's negative 5, negative 1, positive 1, and 0. Okay? So here's what we're looking at right now. If we have k values, okay, if k equals 1, that would be x minus 1, x minus k. When k is negative 1, well, that's x minus negative 1, the whole opposite thing that we were working with before. So you've got this statement here, x plus 1 and x minus 1. Okay? If you take this statement here, remember, this is your constant, and this is your first degree part. What we're looking at there is 5x minus 1, which is the other one here. So these are the factors. Okay? If you want to know what this ends up becoming without dealing necessarily with, well, there's 2 ways to go about doing it. Number 1, you can set 5x minus 1 equal to 0 and solve that. Okay, and get your answer that way. Or you can continue with synthetic division. We can use the 5 and the negative 1, and we can go ahead and use 1/5 since that was one of our choices. All right, and then I know it's kind of freaky to have a fraction there, but 1/5 times 5, that is just 1. So we do end up with no remainder again. So the 3 roots. We knew there would be 3 because the degree is 3. All right. The 3 roots are -1, +1, and 1/5. Alrighty. That is kind of it. We really have already been doing a lot of it before. The big idea is that the number of zeros matches the degree of the polynomial. Okay, this one here has a degree of 3, so we're going to determine the 3 zeros or roots. If you remember, I think it was maybe Tuesday last week, talked about how zeros and roots and x-intercepts are virtually synonymous. Alrighty, I've got this filled out for us so far. Bring down the 2. 2 times 1 is 2. Add them together, you got 3. Multiply, add, multiply, add. Okay? So at this point, you've got an option. Okay? You can go ahead and take this quadratic and solve it, or you can, well, go a different route and keep going with synthetic division. If that's what we're going to do, well, I'll take the new statement 2 or 3, -2. Okay, and we just try out the other numbers. -1, we can see if that works. And it doesn't. Okay, so we can try -2. Bring down the 2. We get a 4. That's a 7. I'm pretty sure that's good enough for us to know it's not going to work. Let's try -2. That's going to give us -4, -1, +2. Okay, so that one ended up working. Now, just like this gave us that polynomial, this one here, remember, is the same thing as saying 2x minus 1. Okay, you can either set this equal to 0 and solve it, you're going to get 1/2, or if you just really like using synthetic division, well, we already know it's going to be 1/2, so I'll just put that down. 2 times 1/2, +1, and they cancel out. So determine the 3 zeros. The 3 zeros, our x values, happen to be the number 1, -2, and 1/2. In no particular order. When you guys are on Schoology, keep in mind you are going to need to put them in numerical order when you're inputting anything, if it's a free response. But otherwise, there you go. Let's see. Where'd the -1 come from? Let's see. If you're referring to this -1 here, it's basically just off of our list. Okay, now I'm going to be showing you in a future lesson where this list of numbers comes from. Okay, so for right now I'm just going to be giving them to you, but we tried the number 1. It gave us a remainder of 0, so that is one of the zeros, one of the roots. Then we used -1. Okay, it's just one of these choices. We have +1, -1, +1/5, and -1/5. We did the 2 1s and the +1/5. We never had to try the -1/5. If we had tried it first, it wouldn't have worked. Since we found the 3 roots that we were looking for, because that's how many there will be, well, you don't have to keep looking once you found them all. The 1/2, same story. Okay, right here, that is, again, for the moment, I'm just giving you numbers to try. Okay, so the only numbers that are worth your time trying are these 6 numbers right there. Positive or -1, positive or -2, and positive or -1/2. Okay, at any point you can do any one of those 6. Now we know there's only going to be 3 answers. Okay, once we've found 3, we don't have to keep going. I recommended earlier, go ahead and start with +1 or -1. Those are most of the time going to be roots. Okay, once we found that 1 worked and that -1 worked, well, you were left with this polynomial, which you can solve it, add 1 to both sides, divide by 2, or use +1/2. You do not need to use the -1/2 since it's not one of the zeros. Basically, it's kind of like, hey, I lost my keys. It's somewhere in my house. So you can go into your bedroom and look, and maybe they're not there. So you go into your bathroom and you look, and they're not there. Now, you've got other rooms in the house. Let's say you go into the family room and you find them there. Okay, so you found them in the family room. Do you still need to go look in your parents' bedroom? You don't have to at that point because you already found your keys. Now, when you didn't know where the keys were, would it have that been a place that you could have looked? Sure, you could have looked there because that is a room in the house. Really, that's kind of all I'm doing is I'm giving you all the possible places where you could look for the keys, as it were, in this case, the roots. All right, once you found all of the roots, well, you don't have to keep looking because you found them all. And that's what the fundamental theorem of algebra is kind of going to be about, is it's telling you how many roots there are. Okay? The last couple we did, there were 3 roots. Well, once we've identified 3 roots, you're done. There's not going to be a 4th one, I promise. If you've only found 2, well, you need to keep looking until you find the 3rd one. Alrighty? As far as where the numbers to come from, the numbers to choose from are coming from, that is the rational root theorem. If you looked in the folder under where it says day 7 rational root theorem, you can see that that is an upcoming lesson. All right, these 2 things, fundamental theorem of algebra and rational root theorem, they are so intertwined together that it's almost hard to do them separately, but we're going to, so I just don't overload you with stuff all in one shot. Okay, let's do a little bit of multiplicity, and then that will be, I think, a good place to stop. I don't want to make a super long video. We can finish up at another time. But find all the zeros for this function. Now we look right here, and that's a number 4. So we know there's going to be 4 zeros, okay? If we find 2 of them, well, we need to keep looking. If we find 4 of them, we're done looking. If we find 5 of them, somebody made a mistake somewhere because there's only 4 of them. All right? These are all of the roots that we could possibly try. All right? Yeah, there's 12 numbers that are worth checking out. Okay? As always, I highly recommend starting with 1 and -1. So we've got 1, -7, 13, 3, and 18. And we'll use 1. Bring it down, multiply, add, multiply, add, multiply, add, multiply. Yeah, that's not 0, so this one did not work out. Alrighty, so use synthetic division to try -1. All right. Break it down. Multiply. Add. Multiply. Where'd I get the 13 from? Right here. I'm thinking is what you're thinking about there? Maybe? 1, -7, 13, 3, and 18? Yes, no? Okay. Let's see. So that's giving us 8, 9, 10, 11, 21. That's going to be -21. Plus 3, you've got -18. And, oh, I forgot to fix this one. That is definitely supposed to be a -18 there. My mistake. Positive 18, remainder of 0. Okay, this is your constant, first degree, second degree, third degree. Here's what you're looking at. Factor out the x plus 1, which is your -1, and now you have a third degree polynomial. Okay, so it's going to have the exact same roots as the original. All right, this is that depressed polynomial that we were using earlier. Okay, so now we can use this one. 1, -8, positive 21, -18. That's been corrected. And we try 3, and it looks like that's going to work. 3 times 1, add, multiply, add, multiply, add. Okay? So the next statement here, since this is 3, remember 3 is our k, and the format is x minus k. So it's going to be x minus 3. So now we're looking at this factored polynomial here. Okay. Now this quadratic, the last two factors are going to be x minus 2 and x minus 3. You could get that, dare I say, factoring. I know we didn't study that. You can use quadratic formula. You can use completing the square, or you can just continue with synthetic division. Okay, we know 2 is going to work. And we know that 3 is going to work. Where did I get that 3 from? From the list. Up here, these are all of the numbers that are worth trying. Okay, we're basically going back to the keys example. You're basically living in a house that has 12 rooms in it, and you've got 4 sets of keys that you need to find. So you just start looking in one room and go from there. All right, we started in room 1, and it wasn't in there. So then we went to room -1, and we found some keys there. Great. So now we've only got 3 sets of keys left to find. Then at the bottom here, you can see we used 3. So we didn't go to these rooms yet, but we jumped over to room 3, okay? And we found a set of keys, all right? Then we jumped down and we went to room 2, and we found a set of keys. And then for some reason, we decided to go back into room 3, and we found another set of keys in there. There were more than one set of keys in room 3, okay? So going on this means that the 4 zeros for this were, and I kind of already forgot what they were, yeah, -1, 3, 2, and 3. Okay, that means that the root 3 is a 0 twice. All right, and that's the word multiplicity. Multiplicity. Okay, so it's got a multiplicity of 2. Multiplicity, I usually describe it, and pardon this one, but it's a lot like a fat guy in an airplane that's being told they have to buy 2 plane tickets, and so because he's going to take up 2 seats. All right, so if we're looking at a graph, and we are going to get to graphing eventually, but remember, roots, zeros, that would be the same thing as saying x-intercepts. Okay, here's -1, here is 2, and here is 3, but remember that has a multiplicity of 2, so it's counting as 2 of our 4 roots. Okay, but that is multiplicity in the shell of a nut. I think that's enough staring at your screen at the moment. You've got the homework in Schoology in the usual place available for you. Of course, I'm on Remind all day, regardless of whether or not you've whether or not it's during the specific time frame for your class period. Alrighty, what I've written down is saved in or will be saved into your folder in just a couple of minutes, and I'll also have this video, slightly edited of course, uploaded in there shortly, so you can watch it again, or if any of your classmates weren't on during this time, you'll be able to they'll be able to watch it. All right, and that is it. Please let me know how it goes, if there's any major issues that you found other than the couldn't connect on the laptop bit. Let me know, and I will do my best to fix any of those. I am already going to be working on the laptop issue. I'm pretty sure it has to do with the fact that I didn't make the channel kid friendly, so that should fix that. But I'll be doing some testing on that later on. I'll use my daughter's laptop for that, since it's under the same restrictions as yours. All right, guys, that's basically it. So I will see you guys later. Be sure to contact me with any questions.